I'd like to welcome Venkata to ArgoCon. Venkata is a staff engineer and the developer platform team at Intuit. The primary focus for them is to make simple, scalable, and reliable Kubernetes clusters the de facto platform for developing, deploying, and running apps. In the past, Venkata has worked as a site reliability engineer for QuickBooks Online, which is the core and the center of Intuit's small business ecosystem, where he designed solutions for high availability, disaster recovery, and cloud-ready initiatives. Welcome.
Today, we're going to talk about add-on deployment at scale using Argo ApplicationSets. My name is Gunapati. I work for Intuit. A bit about me. I work in a Kubernetes technology platform team inside Intuit. Currently, my primary focus is to provide a scalable and reliable Kubernetes infrastructure to all Intuit developers. Most of my career, I have worked on open source technologies and cloud platforms. Here is the agenda that we are going to go through. We're going to talk about what problem we are trying to solve and how ApplicationSet will help in that regard and the benefits of it. And then we will also touch upon how we can leverage least privilege security model that Argo CD provides. And then finally, we'll jump into a demo, and then I will open up for questions. So a bit about company I work for. Intuit was founded in 1983. We are in 19 different locations throughout the globe. We serve about 60 million customers. Intuit is a global technology platform that helps consumers and small businesses in their important financial challenges through tools like QuickBooks and TurboTax and Mint. We'll talk about how we leverage Kubernetes to deploy all these apps and serve customers. So today, we manage about 250 plus medium clusters in Intuit. So they are running about 11,000 plus applications on them. All these applications are primarily using Argo CD and Argo rollouts as a standard mechanism to deploy to the Kubernetes infrastructure. So we also run 20 plus add-ons in a given cluster to make that production ready in order for logging, metrics, and all of that. We'll talk about how we deploy them in the past and how ApplicationSet helped kind of it. Let's talk about, before we dive deep into this, let's understand a little bit of basics of what is an add-on kind of a deal. So generally, the add-on is which extends the functionality of Kubernetes. You can think of examples like Prometheus, Argo rollouts, Istio for that sort of example, right? Now, if you think about what does Prometheus do? Prometheus is responsible for scraping metrics from different parts in a completely different namespaces, which requires cluster roles and role bindings for you. Which needs elevated privileges is what I meant to say, right? So you need to have cross namespace accesses to scrape all this information. So generally, most of the add-ons, if you think about Argo rollouts in that space as well, it provides the custom deployment strategies, and then people apply these cross namespaces. So, and the second point about it is these add-ons are generally developed by different teams. They have a different release cadence and different time of different upgrade cycles and all of that, right? So we need to manage that. And the third point about it, they have elevated privileges, and then you need to think about how you manage the security aspect of it. So the challenges that comes with the add-on is that we have different life cycles for each add-on and different velocities that they want to go at. And now when you manage 250 plus clusters, and then you want to deploy these 20 add-ons, you get a lot of challenges. Like let's imagine this as a scenario that you have cut a release, and then you're rolling out these 250 clusters, and then suddenly that like 4 more add-ons want to change something, right? How do you manage all of this? This picture illustrated really well, where like you have too many cooks in the kitchen, where the platform team is trying to combine all of this together with K8s changes and add-on changes and all of that. And then you need to coordinate everything together. Now, this is the before state on how we used to deploy add-ons, where every add-on is bundled up into a single monolithic repo, and we used to run BDDs for that, and then do a release, and then we need to roll out to these 250 plus clusters, and then the whole process repeats again. Now, the problems is that because it's a monolithic repo and we are coordinating a lot of stuff, the releases are really long. Releases take really long, but this affects the developer productivity, that whoever is developing these add-ons. Now, we wanted to try and see if some other tool can help in this narrative, and ApplicationSets come to rescue, essentially. Before we dive into ApplicationSets and all of that, let's talk about quickly what is an ApplicationSets. ApplicationSets is a controller implements Kubernetes CRD, which works alongside with Argo CD. This gives you a great flexibility to deploy a single app to large fleet of clusters, right? And then you can also do multiple apps to large fleet of clusters, all of that. It also leverages all Argo CD power. We'll go through a demo there where I can show you much more details. And also, this one additional feature is that it could reconcile based on changes in GitHub, as well as additional labels on the Argo CD clusters itself. Here is a typical example of how ApplicationSets CR would look like. There are two important sections that I want you to look at. One is a generator, another is a template. So generator is responsible for generating parameters that renders into the template. If you take a look at this example quickly, so I have this value section here and a cluster section here, right? This is using a list generator. So if this values section is literally but a key value pair. So if you take the cluster, so if you look at the template section where we leverage those values that we submitted, so if you look at the path, it says values set path. Whereas you also see that in the destination cluster where it needs to be deployed, you would say cluster here, which is getting captured from here. So the template, so the generator generates these values and pass it to template, and then template's responsibility is to generate Argo CD applications based on those values so that it can deploy to appropriate clusters with the right parameters. So here is a typical flow. How would it look like? You would have Argo ApplicationSets CR, which gets submitted into Argo CD, and Argo ApplicationSets controller will reconcile and then generates all these apps for you, Argo applications, right? For each individual cluster, depending on how those parameters structured it, essentially. Now, it would then, so then the responsibility is handed over to Argo CD, and then Argo CD is responsible for deploying these add-ons directly into the clusters. So in Intuit, at least the way we structured is this high-level, this is the whole high-level overview. There is a base repo and then an add-on deployment repo. I will go in detail of what these base repo contains and add-on repo contains in a second. So if you look at what does base repo contain, the base repo contains two CRs. These are Argo CD CRs. One is a project YAML in Argo CD, another is an application YAML in Argo CD. The project YAML is responsible for governing what KTS resources then this project can deploy, which namespace in the remote cluster this can deploy to, who can sync it, right? And also which GitHub repo can deploy this particular add-on, for example. All that could be governed and then set boundaries and permissions around. This will help with the security aspect of it, essentially, right? So that's the main intent of the project YAML. The application YAML, when it comes to application YAML, what it is responsible for is that it is looking for ApplicationSets CR in the add-on repo. That's all it is looking for. So it looks for ApplicationSets CR, and ApplicationSets CR is responsible for generating all these apps, as we talked about in a bit. So when it comes to add-on repo, what does it contain? It contains one ApplicationSets CR, which is responsible for providing how you want to structure your waves, how many clusters you want to deploy to, what versions you want to deploy to, and all of that. Now, when you're structuring your add-on, you could use any of these that is supported by Argo CD, customize Helm or KSonnet. Any model is okay, and you can use even bare YAMLs if you choose to. that's one way of doing things, right? So you could also think about how can you leverage least privileged security model that Argo CD provides, where you could think of that the prerequisites could be split from the main add-on, where your platform team deploys them ahead of time for you and make them available, right? Like also there will be central components, for example, like private links and stuff like that. We are Amazon shop, so I put an example of private link. But you could think of any central components as well. If you They will be deployed ahead of time for you by a platform team and then make available. Like, for example, if you take event router as an example, as an add-on, you can create namespace and the cluster role bindings that is required for event router ahead of time. And then if there is any private link for Kafka, for example, you can create all of that ahead of time. The platform team will make them available. When it comes to add-on deployment and what add-on team need to worry about is all about their application and then what they need to watch for, essentially, right? So that way, the security aspect for what you provide to add-on will comes to very minimal, because at that point, all that add-on team is deploying is namespace scope resources, not cluster scope resources. So you could also get away. That way, security team will be super happy, I would say, right? Now, coming back to this, right, if you don't have a need to split the RBAC, you can deploy as one entity, as I shown earlier in the example. And let's jump into a demo. Okay, so I have put together this GitHub Arg for this demo purposes. I will pull up my terminal here. So let's talk about quickly what I have set up here for you, and then we'll jump into. So I have a cluster running, where I deployed Argo CD and Argo ApplicationSet controller running alongside with it. So you see that this is Argo CD and this is our Argo ApplicationSet controller running in this cluster. And then we'll jump into UI. Okay, so right now there is nothing really here, right? So what I have, the setup at least here is that I have linked my GitHub repo that I showed you for demo purposes here. And the other part is I used a V-clusters, it's a virtual clusters, and created for this demo purposes 20 clusters here, and then linked up to Argo CD. Okay. So that's the pre-setup I have done. And let's go through an example here quickly. So what this is so we talked about a base repo and an add-on repo. So first we'll go through a base repo and add-on. I'm taking for an add-on example, Argo workflows here, and then you could use any add-on, but just for this demo, I'm using Argo workflows. So let's deploy the base, and then so base contains app folder, and for each add-on there is a directory here. If I go into the directory, what it contains is two things, as we talked about. There's a project YAML and there is application YAML. Project YAML defines what is the source of where this add-on lives and which clusters it can deploy to, what namespace in the remote cluster it can deploy to, and what are the permissions that it has and what whitelisting that it needs to be done and who can sync it. For this demo purposes, I whitelisted everything, but you could list one by one as well. One by one permission that you need. And the application is a typical Argo CD application, but all it is looking for is it is looking for in the remote repository, in the add-on repository, there is a path called ApplicationSet directory. All it is looking for is that particular path. That's it. Now let's go back to this. What I will do is I'll copy up this link and then let's go to Argo CD and we'll create a new app. So I'll call it add-on base. And we'll deploy to project, and then we'll give this, we'll put that, and then we'll say apps as a directory. We'll also say recursive because we want to pick up all the YAMLs in the directory. That's why we're saying recursive here. And this particular YAMLs will be deployed to the local cluster where Argo CD is running. To Argo CD namespace for this demo purpose. And I will create this. Now, once this gets created, what happened behind the scene? So if you look at this, right, it discovered like there are 3 different applications and all of that. 3 different applications and 3 different projects. Essentially, what we'll do is we'll first focus on workflow, and then I'll go through the rest of it as well. So what I will do is I will sync this project for workflows. What it does is that behind the scene, if you go and look at it in the projects, now you have a workflow, right? And then it defines where it can deploy to and all of that. This is what we have seen in the YAML, literally. Now, I will also do a sync of the application set. What this is doing is it is literally looking for application set folder in the cluster, right? So this is literally looking for application set cluster right there in the Git repository right here. Now, I can do a new. Okay, so this doesn't work. Yeah. So if you look at, so what this contains is 2 directories. This add-on GitHub contains 2 directories. One is application set and one is Argo workflows. Now, application set is literally the application set YAML that I showed you earlier in the demo as well. It has a generator section, template section, and it has a sync policy that how we want to sync, right? All of that. Now, in this case, what we are saying is we want to deploy to 2 different clusters, but we want to deploy 2 different versions, where V1 should have 3.2.4 Argo workflow version, whereas V2 cluster, we want a 3.2.0 version, right? I'll show you how that translates in the UI as well. Okay. All right, so let me sync up this as well, the application itself. So what's happening is behind the scene here is that so because of we said saying, now it looked up at application set path right here, and then it picked up that there is a YAML for application set. And if you look at this, this is the YAML that application set was okay. So this maybe font is super small. Yeah. So if you look at what it is that this is literally what I showed you earlier, that it has a V1, V2, and their versions essentially, and this is using Helm here in this example. You could use customize or anything else as I give you whatever Argo CD supports that works here essentially, and the sync policy I've set. Now, what this generated is that this application set generated 2 different applications in here, one for V1 cluster 1 and another for V cluster 2, right? Now, what that translated to is 2 different apps in Argo CD. If you look at what it is, this deployed full-blown add-on for you, workflow add-on. And the workflow add-on is running, it deployed all CRDs, all cluster roles that is required, and everything is done, right? Now, this got deployed to both clusters essentially, right? And if you might think that this is an independent workflow, I could delete it, right? So you could try and do it because you did not deploy this add-on directly. Now, Argo application set controller will say, hey, this is out of sync for me, so I'm going to recreate this. So as soon as it notices that there is the add-on that got deleted in a given cluster, but it is watching for it, now it would automatically recreate that add-on essentially. But if, let's just say you wanted to get rid of that cluster, you don't want to deploy anymore. Now, Argo CD tracks all of this, all the resources that it deployed to. So you can literally go into your application set. Right now I'll do it here, but you could do it through Git as well, right? I could literally say I could get rid of this section. I'm saying, hey, I no longer want to deploy to C1. I only want to deploy to V2 going forward. Now, if I go back in here, in a second it should realize that there is a def, and then it should automatically remove V1 essentially, and only V2 should be available. Let me go back to this for a second. So this is using a list generator, but I have another example for you. There are multiple generators that are available. So if I go back in here, so I have another AppSet YAML. This is using a cluster generator. There are multiple generators. If you look at this, this is a documentation. Yeah, so this is a documentation for Argo CD, Argo ApplicationSets, and then you could look at what is the cluster generator do, right? Cluster generator uses Argo CD cluster metadata information to generate these clusters, to generate cluster lists essentially, right? Now you can set up all these labels on the secrets that, as I explained here. And then I'll show you a quick demo of how we have structured it essentially, right? There are multiple generators. If you look at the generator section, there's list generator, Git, cluster generator, and Git generator, for example. You can pick and choose for the use case that you're trying to solve for. So here, what we are saying is that I want to deploy to all clusters which has an environment variable dev, this particular version. Whereas all the clusters which has environment prod, I want to deploy this version, essentially. N and N-1, you can think about that, right? Now, so we'll see how this translates to in a second. But before we do that, I'll show you what this means. Where is these labels coming from? So if you look at, so if you get a secrets in Argo CD namespace and say label equal to prod, you will see that all these clusters has a label prod essentially, right? And then all these, you could add additional labels as well, right? I'm just showing a quick example. All these clusters as 11 through 15 has a dev label, for example. Now, let me just move this up. Okay. So the same GitHub repo code is, I have opened it here. I will just move this up into ApplicationSets directory, and then I will make a commit. Okay, so just with that push, what happens is that it is always constantly watching. So what you're supposed to see is that it is, we should see that this should, okay, let me do a refresh here. It understood that there is a new ApplicationSets YAML that got deployed that use selectors. Now that is targeting clusters 11 through 20, right? It's trying to deploy the add-on to all clusters essentially, right? So, and then the way I structured this as well, if you look at this, right, I'm pushing this environment on labels for all applications. So what it helps with is that you could label and go to like, hey, show me all dev clusters in Argo workflow project, literally. And then it should show you all the dev clusters kind of a deal. And show me all the prod clusters, for example, right? So this cluster finally reconciled and it's deployed to it as well, right? And that's how that functions essentially. Now, let's say you, for example, in here, let's go back quickly here and look at dev clusters. Now you have 11 through 15 dev clusters. Let's say a new cluster comes back into Argo CD tomorrow, a dev cluster. What happens then, right? So you could think of patch. So I'm going to patch cluster 10 with a dev as a tag on it, right? So as soon as I patched it, if you go notice it, it already detected that the cluster 10 got added into my pool, that I need to deploy Argo Workflows 3 to 4 version to that dev cluster automatically, right? Whereas if you look at the prod clusters, it is deploying 3 to 0, and the dev clusters is deploying 3 to 4, for example, and then it detected and it deployed, right? So that's one way of doing things, and then so that's the high level idea. Now, we talked about the least privilege security model that Argo CD provides and how you want to leverage that as well, right? So now let me go back to to the base. And we have two more here. One is the event router, and then one I call it platform ENG. So platform ENG is responsible for deploying the RBAC for the event router. And the event router itself is deploying the actual add-on that it, actual deployment and the config map that it needs. Let me sync up this whole directory now. And I'll go and show you what it means here. So if I go back to the base one more time, so and then apps directory, and I have a platform ENG directory. All it says is you can deploy to any cluster with any permissions. But if I go back to, the AppSet YAML is just looking for application set in that GitHub repo. That's all. There's nothing much. But whereas event router project YAML has no permissions, no whitelisting. What that means is by default, Argo CD only gives you to deploy namespace scope resources. You would not get any permissions to deploy cluster role bindings, and all of that, right? Now, if I go back to the apps itself, if you look at this, the platform ENG has an event router directory, and all it has is a bare YAML. It is not even a Helm chart. It contains this namespace that it needs to create, the service account, and the role and role binding. That's what the platform team is deploying for you in this case. Now, whereas if I go back to event router itself, so if this add-on is managed by another team, they can iterate on this themselves. Essentially, this deployment only contains a config map and then a deployment, literally, right? So that much. Now, if I go back to Argo CD, what had happened, and I could do literally filter here, and then do a project selection, and then platform ENG. So platform ENG deployed to 3 different clusters, the prerequisites. And then if I look at one of the prerequisites, it deployed the cluster role binding and namespace and all of that. Now, when I go back to event router is trying to deploy the event router itself, and then that their application set is controlling that. And then it's deploying all of this to their cluster. Okay. So I can show you this, for example, you deploy the config map and the deployment. It will eventually roll out to all clusters that way. And that's the high-level understanding. If you want to split out, you can do that. But if you don't have to split out and you can deploy everything together, you can follow the Argo CD, Argo workflows example I showed you. That concludes my demo. Let me get back into slides quickly. So what next? So next is that we are trying to come up with a new generator called mixed generator. What it's supposed to solve for is if you have if you want to do both clusters generator and a list generator in a single CR, where let's say you have 20 dev clusters. But out of those 20 dev clusters, you use label selector to select all 20 dev clusters. But one of them is a snowflake, and you want to deploy it a different version, or you want to roll out to that cluster a little late. So you should be able to put a list and cluster generator in a single CR and say, this one cluster, I want to roll out a different add-on versus the rest of the cluster, right? A different version of the add-on. Now, and the second thing that we are working together, and Alex from Argo team is helping me through this, right? So Argo CD has a allow/deny list today, but it is not fine enough. It permits you to provide a group and a kind. Now we want to restrict more, essentially, to be able to say, let's say SERD is deployed by one add-on. We don't want another add-on to deploy the same CRD. That is not possible today with the whitelisting that is allowed. So we're trying to make it more fine-grained. And then these two are links, and you could look at, for example, I can just take it quickly. So the idea is to do spec-based, and then you should be able to restrict it, saying what specific CR they can deploy through this add-on, essentially. And that's it. Thank you very much. If you have any questions, I'm open for it.